Hey guys, as promised, I wanted to send you out, just send you a video of doing a few examples of these solving two equations with two unknowns. This is just such an important concept. I want to make sure that you guys understand it, and we only had time to do one example in class. So I'm going to walk through these. If you're confident that you've already got this down, then there's no need for you to watch this video. What you might want to do, I've copied 3 problems on the whiteboard here. You may want to just try to work those, and then you can fast forward and see if you got the correct answer, and you'll be good. But for those of you that are still struggling with this, I want to make sure that you understand it, because this is something that's going to come back over and over again in your math career. So the way that we're solving these two linear equations here is that we're going to use the substitution method. There's another method, the elimination method, that we'll review in a future lesson. But for now, we're going to substitute. And as I said in class, the idea is the same thing that we've done before when we've used numbers. Like if I've given you an equation that looks something like this, this is a really simple one, right? And I told you that x equals 5 and told you to solve for y, then you would just plug in 5 in for x, and you would say y equals 10, right? It's the same idea. We're substituting in, we're substituting in for a particular variable so that we can solve for the other variable. So that's what we're doing here. And we'll just, in these particular equations, they've already made it easy for us in that they've solved for a variable already. And so we can see that in each of these second equations here. The first 2 set of equations are solved for, the bottom equation is solved for x. This one here is solved for y. So we're basically going to take that equation, whatever x is equal to here, and we're going to plug that in for x up here, right? So that's how we're going to end up solving for y in this case, and then we'll be able to substitute back in whatever value we find for y and solve for x. And I just realized I had a typo. So that first equation shouldn't be, this second one shouldn't be x equals negative 3x. It should be x equals negative 3y. So let me fix that. All right, so here we go. So we're going to take this value, again, we're going to take this portion of this bottom equation here, because that's what x is equal to, and we're going to plug it in for x in the top equation. So we say that 2 times negative 3y plus 11 minus y equals 1. All we did was plug that value in for x in that top equation. And when we distribute, we're going to get negative 6y plus 22 minus y equals 1. When we get all of our y terms on one side and our numbers on the other side, we're going to end up with negative 7y on the left side here and negative 21 on the right side. And then if we divide both sides by negative 7, we get y equals 3. Now we're going to take that y equals 3, and we're going to plug that back into this equation right here, because if we do that, then it'll tell us what x is equal to. And we actually could plug that y into either equation, either of the top equations there. It doesn't matter. It's just that since this was already solved for x, the math will be simpler, okay? So we're going to say x equals negative 3, substituting in 3 for y, negative 3 times 3 plus 11, right? I'm just plugging that in right here. And I'm plugging in 3 into that equation. And so that means that x equals negative 3 times 3, which is negative 9, plus 11. And so x equals a positive 2. So for this one, y equals 3 and x equals negative 2. That's the solution for this system of equations. All right. So let's move on and do another one. Again, they've already solved for one of the variables in the second equation here. So we're just going to take the value of x that's given to us there and plug it back into the top equation. Okay, so we have 3 times 3y minus 10 plus 2y equals 3. And when we distribute the 3, we get 9y minus 30 plus 2y equals 3. Combining our y terms, we get 11y, and then we move the negative 30 over to the other side to make it a positive 30, and so we have 33 on this side. And so dividing both sides by 11, we get y equals 3. All right, that's our y value. Then we take that y and we plug it into the second equation up top, since it's already solved for x, and we have 3 times 3, since that's what y is, minus 10. And so x equals 9 minus 10, which is -1. And that's the value for x in this problem. So y equals 3 and x equals -1. Just checking my answers to make sure I got that right. And then let's move on to the last one. Now this one, they didn't solve for x in the second equation. But this one, they've solved for y in the second equation. So we're going to take this value for y and plug it back into this equation up here. Okay, so we'll say -x minus 2 times the value of y, which is -3x plus 8, equals 4, right? And so we simplify by distributing the -2 here. -2 times -3x gives us a positive 3x. -2 times a positive 8 gives us a -16. That equals 4. And so combining our x terms, we get 5x on the left side of our equation. We move the -16 over to be a positive 16, and so we get 20 on the right side. Dividing both sides by 5, we get x equals 4. And then finally, just like before, we take the value that we get here and we plug it back into the second equation since it's already solved for the other variable. So we plug in x equals 4 into that, and we get y equals -3, substituting 4 for x plus 8. And so y equals -3 times 4 is -12, plus 8 is a -4. So x equals 4 and y equals -4 would be the solution to this system of equations up top here. All right. As always, if you have any questions, please reach out to me. And Lord willing, I'll see you guys in class on sometime next week, Thursday. All right. Have a good one.